So I'm here with my camper and I'm going to talk about inverters, why you might want one, what they are, and then what went wrong with ours and what we had to do to fix it. Typically in your camper you'll have two types of electricity supplies. You'll have a mains supply, so here this is 240 volts, this charger, so exactly as you would use at home. If you're in America, that would be 115 volts. It's alternating current, and that would work while your camper is parked up at a campsite or at home and you are plugged into shore power or mains power. Or like on your car, you have a 12 volt supply, and they've used these before. It goes into the old cigarette lighter socket or the sort of power socket. This is again just another charger. So here I've got two different chargers, one's for 12 volt and one's for mains. Here in the camper I have I have multiple mains outlets, and I have some 12 volt outlets here. Plug that in and the device starts working. However, if you're on the road and you are not going to be plugging your camper in to the mains, you might want to be able to run some of these mains operated devices just from your camper battery. Now this is where an inverter comes in. This is a admittedly quite small inverter. It's got a clever piece of kit. At this end you can plug into the accessory socket of your car or your camper, and that takes 12 volt DC direct current, and at this end is an outlet for mains power, so that then gives you 240 volts, or if you're in America 115 volts alternating current. The two obviously do not mix, so I won't go into the technology of how this works, but it's quite clever. So you often see these for sale on the internet. Some of them will be relatively cheap and quite small like this one, and they'll plug into an accessory socket. Others will be fairly big pieces of equipment and they'll be very expensive, and they'll need to be permanently wired in with really thick cables. The difference is that the big expensive ones are designed to support high wattage, but what I've had to consider is what I would realistically use an inverter for. If I want to boil a kettle, anything that generates heat is going to use a lot of power. So actually I've got a propane stove, so it's a lot more efficient and cheaper to just use that to heat a kettle or a pan. If I want to heat the camper, again I have a gas furnace, so that can heat the camper. So again, I'm not going to try and run these big high wattage devices off an inverter. What I typically want a inverter to do is to run maybe battery chargers for cameras, or power supplies for laptops, computers, the sort of things that you're probably not going to buy a separate 12 volt version for. You just want to take your 240 volt version from home and use it, and that's where this size of inverter actually works quite well. So this is 300 watts, and most things like small battery chargers, power supplies for laptop computers, sort of devices you use such as this fan, will consume well under 300 watts. So this is sufficient for those, and those are the types of things that an inverter for me would be used for running. So that's why I've only spent, I think this was it's now £55. It was about 45 when I bought it. Now the other consideration, or there's a couple of considerations. One is that your average accessory socket usually only supports, I think it's 150 watts, so that's half of this. So that's fine if you're going to use very low power devices. But this, for example, comes with a separate set of crocodile clips here with an adapter, which means that you can connect this directly to a car battery, and that will draw more current and allow you to operate this without blowing a fuse. Now, you want to buy a pure sine wave inverter. If you look at the waveform of the main supply that comes out of a socket at home. It is a perfect sine wave, or almost perfect sine wave. It's very smooth. Now, if you looked at the output from this inverter, and I've done that with an oscilloscope, it's almost the same. So it's very good. Now, a previous inverter that I had and got rid of, it wasn't. It was called a modified sine wave inverter. And when I put the oscilloscope on there, it was almost a square wave. And the problem with that is that, well, without going into details about harmonics and frequencies, is that it's very bad for certain electrical devices. So I did plug in a power supply for a laptop computer into one of those modified sine waves inverters, and it blew up the power supply. So that's why you want something that says pure sine wave inverter. So now we know what an inverter is and what you might use it for. What went wrong with ours on our recent trip into France, and what did I have to do to fix it? Haven't even left the UK. The first glitch of the trip is the inverter stopped working. Now that turns out I'm not going to be able to fix that without soldering iron, because the transformer's actually broken away from the PCB. I had a problem with it a while back in that it had a, well, it was my fault. I wired an accessory socket on the camper the wrong way round. When I plugged this in, it's got a diode that shorts out if the supply is the wrong way round, and then it blew an internal fuse. But that was a fuse soldered onto the PCB, so that was rather annoying. So I bypassed that fuse and then added an external circuit breaker, big clunky thing I had knocking around in the garage. The latest favourite is, when Bestech built this, they have this big inductor in there, and it was just held down by double-sided sticky tape here, and of course over time that's failed, and then the whole weight is held on these very small wires, these varnished wires. Of course, then once you go move it and knock it about, this just breaks off entirely. So I'm going to look at soldering that back on, but obviously I've lost the end bits of the wires, so I can solder some lengths of wire on and then take them back to the PCB. But I'm not going to just use double-sided sticky tape. I'm going to do what Bestech should have done in the first place, which is drill a couple of holes and then put a cable tie round to make sure that on the other side, obviously, is securely held and can't move. Okay. Extended those varnished wires out, so now I can solder that onto here. Right, it's a bit more secure. It's really how it should have been in the first place. So the big question is, will this work or will it go bang? Put it down so see if there's smoke. Right, on. Green light, that's promising. Okay, let's plug a load into it. This is off. Turn it off. Turn it on. Oh yes, we have an inverter. Fantastic. And all because they used double-sided sticky tape to hold the inductor in place, which was rather daft, instead of a cable tie, which is what they should have done in the first place. Well, that would have made life a lot easier on that trip to the Pyrenees when the alternator stopped working or stopped supplying voltage, if I could have just used this to run the fridge. Anyway, that's good.